Have you ever wondered what a day truly is? It's not just the time between sunrise and sunset. In the grand cosmic ballet, a day is the time it takes for our planet Earth to complete one full spin on its axis. Imagine a spinning top. Our world does something very similar, turning and turning in the vastness of space. For centuries, we have defined this spin as lasting exactly 24 hours, or 86,400 seconds. This rotation is the master clockmaker of our lives. It dictates when we wake up, when we eat our meals, when the sun warms our faces, and when the stars come out to play. Our entire society, from school timings to shop opening hours, is built around this beautifully reliable planetary rhythm that has been with us since the dawn of humanity itself. For as long as we can remember, this 24-hour cycle has been a constant, a dependable beat in the song of our lives. We set our watches by it, plan our futures around it, and trust it completely. But the universe is a place of constant change, and nothing, not even the length of our day, is immune to its subtle shifts. Scientists, with their incredibly precise atomic clocks, timekeeping devices so accurate they won't lose a second in millions of years, have noticed something peculiar. They have discovered that our planet is starting to spin just a tiny bit faster. This means some of our recent days have been ever so slightly shorter than the standard 24 hours we are all used to. It's a change so small you would never notice it, but it's there. Take, for example, the day of July 19th, 2020. On that day, the Earth completed its rotation 1.47 milliseconds faster than usual. A millisecond is a thousandth of a second, an impossibly tiny slice of time that you can't even perceive. You might think, what is the big deal about a millisecond? But when you add up these tiny fractions over time, they begin to matter a great deal, especially in our high-tech world. It's like a clock that runs just a little too fast. At first, the difference is negligible, but eventually it will be noticeably out of sync with everything else. This discovery has sent ripples through the scientific community, prompting a fascinating investigation into our planet's changing pace. This acceleration is a relatively new phenomenon in our recorded history. For a long time, the Earth was actually slowing down, not speeding up. This was mainly due to the gravitational pull of the Moon, which creates tides and acts like a gentle brake on our planet's spin. To keep our clocks aligned with the slowing Earth, timekeepers would occasionally add a leap second to the year. But now, the tables have turned. The planet has put its foot on the accelerator, and we are entering uncharted territory. Scientists are now keeping a close watch on specific dates, such as those in mid-2025, which they predict might set new records for the shortest days ever measured. It's a cosmic mystery unfolding right beneath our feet. So, what is causing our home planet to pick up its pace? It's not one single thing, but a combination of complex and fascinating forces happening both deep inside the Earth and on its surface. One of the main suspects is the Earth's core. Deep beneath our feet lies a massive molten ball of liquid metal, swirling and churning like a cosmic soup. Scientists believe that shifts and changes in the flow of this liquid core can affect the rotation of the entire planet. Think of a figure skater spinning on ice. When she pulls her arms in closer to her body, she spins faster. In a similar way, subtle movements within the Earth's core can change how the planet's mass is distributed, causing it to speed up its spin ever so slightly. Another peculiar factor is something scientists call the Chandler wobble. This is a natural slight quiver or wobble in the Earth's axis of rotation, much like a spinning top that isn't perfectly balanced. This wobble has been happening for over a century, but its pattern seems to be changing. For years, the wobble was quite pronounced, but recently it has diminished, almost disappearing. The exact reasons for this change are still being studied, but a less wobbly planet might be a more efficient spinner. The reduction in this wobble could be contributing to the overall acceleration we are now observing, making our planet spin a little smoother, and, as a result, a little faster than it used to be. It's a delicate dance of planetary mechanics. Perhaps the most surprising reason for the Earth's faster spin is connected to climate change. The vast ice caps in Greenland and Antarctica are melting at an alarming rate. As this massive amount of ice turns into water and flows into the oceans, it changes the distribution of weight on the planet's surface. It's like that spinning figure skater again, but this time, imagine her moving mass from the poles, her head and feet, towards the equator, or her waist. This redistribution of mass from the poles towards the center makes the planet spin faster. It is a profound and startling reminder that human activity and its consequences can have effects that reach far beyond our immediate environment, even influencing the fundamental timekeeping of our world. These different forces, the mysterious churn of the core, the calming of a planetary wobble, and the global shifting of water from melting ice, are all working together to shorten our days. It's a complex puzzle that scientists are piecing together with incredibly precise measurements. Each factor contributes just a tiny bit, but their combined effect is now significant enough to be measured by our atomic clocks. Understanding these processes is not just an academic exercise. It's crucial for understanding the intricate systems that govern our planet and how they are changing in real time. Our Earth is a dynamic, living system, and it is currently rewriting its own schedule, millisecond by millisecond. Because the Earth is spinning faster, our human-made clocks are starting to fall behind. For the first time in history, the people who manage our official global time, the International Earth Rotation and Reference System Service, are facing a completely new problem. They are seriously considering doing something unprecedented, subtracting a second from our official time. This is known as a negative leap second. For decades, we have only ever added leap seconds to account for a slowing Earth. The idea of taking one away is a major shift and presents a huge challenge for timekeepers and technology experts all around the world. It's like trying to run a race backwards. It's something we have never had to do before. Why is subtracting a single second such a big deal? Our modern world runs on perfect synchronized time. Think about the technology you use every day. Your smartphone's GPS needs ultra-precise time signals from satellites to tell you where you are. A tiny error could send you in the wrong direction. The global financial system, where billions of dollars are traded in fractions of a second, relies on timestamps that are accurate to the nanosecond. Even something as simple as booking a flight involves computer systems across the world coordinating perfectly. All these systems are programmed to handle time moving forward, and sometimes to handle the addition of a leap second. But they were never designed to have a second suddenly vanish from existence. The introduction of a negative leap second could cause chaos in our digital infrastructure. Computer programmers are worried that it could create a time glitch that crashes systems. When a computer's clock suddenly jumps backward by a second, it can confuse software that relies on a continuous forward flow of time. This could lead to data corruption, system failures, and widespread errors. Imagine banking transactions being recorded with the wrong timestamp, or air traffic control systems getting confused. The potential for disruption is so significant that many tech companies and international bodies are debating whether there is a better way to handle this discrepancy, perhaps by letting the gap between Earth time and clock time grow a little wider before making any drastic changes. This debate highlights a fascinating clash between the natural, ever-changing rhythm of our planet and the rigid, precise world of our technology. The Earth doesn't care about our computers or our schedules. It will continue to spin at its own pace, influenced by deep, powerful forces. But we have built a global society that depends on a perfectly stable and predictable measure of time. The negative leap second is where these two worlds collide. Finding a solution that keeps our technology running smoothly while staying true to the Earth's actual rotation is one of the unique challenges of our modern, interconnected age. It forces us to reconsider our relationship with time itself. If this trend of a faster spinning Earth continues, the consequences could ripple out beyond our computer systems and start to affect our daily lives in more personal ways. At first, the changes would be unnoticeable. A few milliseconds shaved off each day doesn't sound like much, but over years and decades, this could add up. Our biological clocks, or circadian rhythms, are finely tuned to the 24-hour cycle of light and dark. These internal rhythms control our sleep patterns, hormone release, and even our moods. A persistent shortening of the day, even by a small amount, could slowly start to desynchronize our bodies from the natural world, potentially leading to sleep problems, fatigue, and other health issues. Beyond our biology, a faster Earth could also impact the very structure of our society. Our work schedules, legal definitions of time, and even agricultural practices are all based on the 24-hour day. If days become consistently shorter, we might eventually have to adjust our clocks more permanently. Imagine a future where the day is officially defined as being a few seconds or even minutes shorter. This would require a massive global effort to recalibrate everything from school bells to train schedules. It would challenge our legal systems, which rely on precise time for contracts and deadlines, and force us to rethink how we organize our working lives and our leisure time in a world that spins at a different tempo. The prospect of a faster spinning planet also serves as a powerful symbol of our changing world. The fact that melting ice caps, driven by climate change, are one of the key contributors to this phenomenon connects our daily actions directly to a planetary scale effect. It shows that the consequences of our industrialized society are not just local or environmental, but are now geological in nature. We are not just living on the Earth, we are actively changing how it moves and functions in the cosmos. This realization adds a new layer of urgency to the conversations about sustainability and our responsibility to the planet. The shortening of our day is a message from the Earth itself, telling us that our actions have powerful and sometimes unexpected consequences. While the immediate future might only involve a debate about a negative leap second, the long-term possibilities are a compelling thought experiment. Will future generations live in a world with a slightly shorter day? Will they have to adapt their bodies and their societies to a new planetary rhythm? We stand at a unique moment in history, where our own technology has become precise enough to detect these subtle changes in our world. The shrinking day is a cosmic curiosity, a technological challenge, and a profound reminder of the intricate and delicate connection we share with our amazing spinning home in the universe. It invites us to look up at the cosmos and, at the same time, reflect on our impact right here on Earth.